Hey everyone, welcome back. So today we're going to be solving another lead code question on dynamic programming. Okay, the question's called house robbers. Okay, uh, so if you see, I'm not solved this question yet. I'm doing it for the first time, right? So I'll try to figure out the solution with you guys, and yeah, let's get started. The question here says that you're a professional robber, and so you plan on robbing a few houses. Okay, and you're given an integer nums, right? Each I is the house, and nums of I is the amount of money that is present in each of the houses. What your target is to basically maximize the robbery money, right? So the first house contains one amount of cash, second house contains two amount of cash, third house contains three amount of cash, the fourth one contains one amount of cash. So your task is to maximize the profit that you can make on a particular night robbing these houses. But there's a catch to the problem. The catch is that each adjacent house is rigged with an alert system. Basically, if you go to this house and then you go to this house, what happens is, uh, the cops get alerted, right? But then if you go to the first house and then third house, the cops won't get alerted because adjacent houses are rigged, right? So if you see over here, I can rob house one, that is one, and then rob house three, right? I can't rob a house two because if I do that, cops will be alerted, right? What my task is to maximize the profit that I make with the given constraints, right? Okay. Similarly, if you see over here, I can either start with house 2, right, or I can start with house 7. If I start with house 2, I cannot drop house 7, right, because the police will be alerted. So I'll go for 2, I'll go for 9, and then I'll go for 1. Or another way is I can go for 7, I can go for 3, right? So if you see 2, 9 and 1, this is the best option, and yeah, we get a total profit of 12. Right? So yeah, let's get started, and let's look into what the recursive approach is, right? And then let's try to optimize it. Okay. Now, so if you look at this, the first approach that you might think is, why not I try to be greedy, right? So what I can do is maybe I can pick these two houses in the start, and I can see what is greater, right? If 7 is greater, right? So I pick 7. Okay. Then what I do is, okay, I pick 7. Okay. If I pick 7, I know for a fact I can't pick 9, right? So then what I do is I go to 3, right? So I pick up 3, right? So after I pick up 3, I cannot pick up 1, and then I end up with 10. So if I think of it in a greedy way, in that case, I know that I won't get my answer, right? Let's go to the first one itself. I pick house with money 2, right? Once I pick 2, I cannot pick 3, right? I have to pick 1, right? And then I pick 1. So I get a profit of 3, but the actual answer is 4, right? So I know that greedy cannot be applied over here, correct? Because when you're trying to be greedy with your answers, right? But it's not possible because you're not getting the maximum profit. Okay, so we have to think of a better way, right? We have to think of a better way. What is a better way if greedy is not working? Can we think of all the possibilities, right? What by all the possibilities I mean is, uh, possibility of picking 2 or not picking 2, possibility of picking 7 or not picking 7, possibility of picking 9 or not picking 9, picking 3, not picking 3, picking 1, not picking 1. If I do that, I will finally arrive at a point where I get all the possibilities of robbing the houses without alerting the cop, right? Once I get all the possibilities, I can just take the maximum one, right? I think this would be the right approach, right? So let's get started. What I'm going to do is, I'm going to uh, I'm going to you know take an example of the second one, right? It is 2, 7, 9, 3 and 1. Okay, what I'm going to do here is, okay, what I'm going to do here is, let me, instead of going from the start, right, instead of going from here, right, I won't do this. I'll come from this side. Okay, I'll come from the top. Okay, so yeah, what I'm going to do is, let's say ways of robbing one. uh, Ways of robbing, okay, wait, ways of robbing of house 4, right? Okay, it's it can be two ways. Either I'm going to pick the house 4, or I'm not going to pick the house 4. That can be the two possibilities, right? Either I pick it or not pick it, right? Either I pick it or I not pick it. Okay, let's look at the possibility of where I don't pick it. Okay, 4 is the index, so this is pointing at the index, right? This is pointing at the index. Okay, so what I'm going to do is, okay, let's first look at the possibility of not picking it. Okay, if I don't pick 4, what can be my other possibilities? Okay, can I say that if I don't pick 4, I have a chance of picking 3? I can say that, right? Because I'm not picking 4. So this one is not being considered. This one is, if you see, this particular one is not being considered, right? So I, if I'm not picking this, right, I can pick this, right? I have a chance of picking this. I'm not saying I'm gonna pick it. I have a chance of picking this, right? So all I'm gonna do is, I'm gonna be calling ways of robbing the house 3, right? Perfect, perfect. Now, what are the what is the other possibility? The other possibilities, I pick 4, right? Okay. Other possibilities, I pick 4. So when I pick 4, I will take this money, right? If I'm robbing, if I'm picking 4, I'll take this money. So I take 1 plus. What are the possibilities now? Do I have a chance of picking 3? That is this. Do I have a chance of picking 3? No, I do not. Because 3 is adjacent to 4, right? I cannot pick 3, right? If I pick 3, cops will be alerted, right? So I cannot pick 3, but I can pick 9, right? So what I will do, I will call ways of robbing 2. 2 is what? It's the index. 3 is what? 3 is index. Okay, perfect. So we have found 2 of our conditions. Our first condition is not picking, right? And our second condition is a of I plus, sorry, we're not writing equation here, right? Second condition is picking. Perfect, right? Okay. Okay. Now, ways of picking 3, right? I either pick 3 or I don't pick 3, right? So first, I don't pick 3. Ways of, let me just write it as ways. Ways of picking 2. Or another one is, I do pick 3, but I can't pick 9, right? Because 3 is adjacent to 9, right? So what I do is, I go for 3 plus ways of picking 1. Perfect. Okay. Now, okay, now ways of picking 2. Okay, same thing. I have an option of not picking 2, so what I'll do is I'll go for 1. Ways of picking 1, right? Or I have an option of picking 2. In that case, what I'll do is I'll take 9 plus, what I'm going to do is I'm going to if I pick 9, I cannot pick 7 because both of them are adjacent. What I'm going to do is I'm going to call ways of picking 0. Right? So we have hit 0. We cannot go lower than that. Right? So 0 would be our base condition. Right? Because if we go lower than that, we would go out of bounds. Right? So we would go until 0. Right? Perfect. Now, ways of picking 1. I'll either not pick 1, so I'll go to ways of 0, right? Or I'll eh, yeah. Eh, sorry. Now, ways of picking 0, right? Uh, what is the ways of robbing 0, right? So I have two options. Either you pick 0 or you don't pick 0, right? But here the question is not to return the number of ways to do it, but to return the maximum profit. Maybe I should have named my function a bit different, but yeah, you get the point, right? So ways of picking 0 is ideally the profit that I can make only robbing the 0th house, which is nothing but this one, right? So what I'm going to do is, this is our base condition, right? Because we have reached the first point of the array. Anything lower than that would go out of index, right? So what I'm going to do here is, when I hit 0, since this question is about maximizing the profit and not about the unique number of ways, I'm just going to return 2. Okay. Right. 2. And return 2. Minus. Oh, okay. Sorry. Okay, what? It's that, or I pick 1, right? That is 7. I forgot to write this. Ways of picking -1, right? Ways of picking -1, because why? Because I picked 7 and I can't pick 0 because I've already picked array of 1, right? 7 is nothing but array of 1, right? So I cannot pick 0, so I have to go to the element that is 2 houses away from 1. So ways of -1. This is just going to return 0, right? So I'm going to return back 0. Return back 0 over here. Okay. And ways of 0 is going to return me what is the maximum profit that I can make only robbing the house 0, right? That is 2, right? So what I'm going to do is this is going to return 2, right? And 7 plus 0 is going to return 7, right? Now what is the maximum profit that I can make to rob the first house? Until the first house, not the first house, until the first house, right? So until the first house, what is the maximum profit that I can make? If I pick 2, I cannot pick 7, right? Because both of them are adjacent. So I either have to pick one of them, right? I cannot pick both of them, right? So I have to pick one of them. So I pick 7, right? If you look at it visually, what is the maximum profit that I can make to rob until the first house, right? It is 7, right? So that is exactly what our answer is returning to. If you see over here, it is the maximum of these two is 7. So if you see, maximum of these two is 7, right? So what we're going to do is we're going to return 7. Perfect. Now ways of picking 0 is 7, which, so the left subtree has returned 7 to ways of 2. Now I'm going to the right subtree, right? Right subtree is nothing but 9 plus ways of 0, right? Ways of 0, we would just return 2, right? So this would have 11, right? So this would basically return us 11. Okay. Now let's look at it visually. When we look at it visually, what is the maximum profit that he can make to rob until the second house? That is, until this house. What is the maximum profit? Okay, either you pick 2 and then you pick 9, right? Or or you only pick 7, right? If you pick 2, you cannot pick 7. 7 is not possible because it's adjacent, right? So you have only two options: either you pick 2 and then you pick 9, or only you pick 7, right? So maximum is picking 2 and 9, right? So this is going to give us 11, right? So 2 plus 9 is going to give us 11, and this is exactly what our recursive call also has returned. Okay, so we have a profit of 11. So ways of 2 is 11. Okay, now 3 plus ways of 1, right? What is the ways of 1? Number of what is the maximum profit that I can make until house number 1, right? We have already calculated it. The value that I got is 7, right? So this is going to return 7. Okay, 7 plus 3 is 10, so this is going to return 10, right? And this is going to return 11, right? Okay, now let's look at it visually again. Let me reload this. Okay, now so until the house 3, right? Until this particular point, let's look at it visually. What is the maximum profit that I can make robbing the house until 3, right? I can either pick 2 and I can pick 9, right? So the profit for the possibility 1, I have a profit of 11, right? Or right, or I have a possibility of picking 7 and 3, which gives P2 as 10. Right? So if you see over here, that is exactly what we've gotten from our recursive call as well, right? P1 we've gotten it as 11, P2 we've gotten it as 10, right? Perfect. So what I'm going to do is I'm going to pick the maximum one, which is 11. So this will have 11. Now, now ways of picking 2, not ways of robbing, maximum profit. I name the function rob, but yeah, you get the point, right? It's not ways of robbing; it's a maximum profit that you can make until the house 2, right? Which already calculated. It is 11. So what will this return? This will return 11, right? So 11 plus 1 is 12. This will return 12, and this will return 11, right? Let's look at it visually again. So right, so maximum profit that you can make until the house 4, right? So you can pick you can pick 2, 9 and 1, which will give you a profit of 12, right? Or which will give you a profit of 12. 2, 9 and 1, which will give you a profit of 12, or 7 and 3, which will give you a profit of 10, right? So what is our best answer? It is picking 2, picking 9 and picking 1, right? So which is nothing but 12. So possibility 1 is 12, possibility 2 is 11. Not 11 actually. Possibility 2 should be 10. Right, but possibility 2 is 10, but I'm receiving 11 over here. So what are the ways of picking? What is the maximum profit of by not picking 1? It is 7 and 3, which is visually 10, but why am I getting 11 over here? Okay, maybe I made a mistake in my calculation somewhere, right? But you guys get the point, right? Because since our final answer is 12, which was correct, maybe I made a mistake on the calculating the left subtree, right? But yeah, we're gonna pick the maximum one, which is going to return us. Okay, perfect. Now let's code it. Okay. Okay. Let's call it maximum profit of int nums int I, right? That is all I need. Let's come to the base condition data. So I told you there are two possibilities, right? So we're going to return math.max of, first possibility is max profit of, I'm going to take nums and then I minus 1, right? That is not picking it, or nums of I plus max profit of nums comma I minus 2. Okay, so this is the one for picking it, and this is the one for not picking it, right? Perfect. Now base condition would be, first base condition is if I equals to 0, I'm just going to return nums of 0, right? If I is less than 0, I'm going to return 0, right? Perfect. Now here what I'm going to do is I'm going to return max profit of nums comma nums dot length minus 1. Right. Perfect. Let me run this test case. Right, it got accepted. Okay, I'll submit it now. If I submit it, I should get a TLE, right? I know it because I know why I'm getting a TLE, but I will explain it to you once I get a TLE. See, I've not solved this before, but the reason I told you I'm going to get a TLE is because look at the constraints. Look at the constraints. It's 100, right? Length of nums can go up till 100. On the worst case, if it's going up to 100, let's look at what the time complexity will be, right? Let's look at what the time complexity is. For the first one, right? Ways of, if I take 100th element, that is 99, right? I either don't take it, so ways of 98, or I take it, right? A of 99 plus ways of, no, let me not call it ways. This is actually creating a bit of confusion. Call max profit of 99, right? The max profit of 98, or max profit of 97 plus A of 99, right? What about this? The same thing, max profit of 97 or max profit of 96 plus A of 98, right? Similarly, what is it for this? Right? max profit of 96, right? Or max profit of 95 plus A of 97, right? Two options. Right? Similarly, when you keep going, this will, if you keep going, this will have two possibilities, and this will have two possibilities. Similarly, this will have two possibilities, and this will have two possibilities, right? If you look at this, right, in every level of the recursion, we're going 2 power n times, right? First is 2 power 0, next is 2 power 1, next is 2 power 2, next is 2 power 4, till 2 power n we are going. So just think about it. The time complexity of the solution is, right, 2 power 100 on the worst case, which is a lot, right? Of course, you're going to get a tail, right? This is what we need to optimize. Okay, what can we do to optimize? Let's look at the same example that we did. Right? What did I do over here? On the first left subtree, I calculated all the values until 0, right? And then when I was going to the right subtree over here, or over here, or over here, right? What did I do? I already calculated this value, maximum profit of 1, right? I'm just picking that answer from here, right? For ways of robbing 2, what did I do? I already calculated this answer over here, right? In the left subtree itself, I calculated this answer, right? What am I doing? I'm just taking that value and using it over here. I'm not going to make another recursive call over here. I'm not going to make two more recursive calls for this one. I'm not going to do that. Instead, what I'm going to do is I'm going to store this particular value the first try, and then I'm going to reuse it over here so that I don't have to make recursive calls, right? So in that case, if you look into it, how many recursive calls are we making? We're going from 4 to 0, right? And then we're storing all the values. So the number of recursive calls we're making is nothing but n, right? So if you are storing it somewhere, your time complexity would reduce from 2 power n to n, right? Right? Sounds good, right? Let's try to implement it. What I'm going to do is I'm going to have a DPI, right? This is nothing but DP, dynamic programming, and this concept is called as memoization. You're storing the value and then you're using the same value somewhere else, right? So what I'm going to do is I'm going to initialize a DP into DP nums dot length. Yes, nums dot length. And then here I'm going to pass DP as a parent. Here I'm going to receive DP as a parent, right? And what I'm going to do is, okay. Now, so can my answer be 0? Can the maximum profit I made for a house, can it be 0? Or can the maximum profit I made until certain houses, can it be 0? Yes, it can be 0, right? It can be 0. So what I'm going to do is, if my answer is 0 and if the default value of the DP is also 0, will that create a confusion? Yes, it will create a confusion, right? Because I don't know if that is the default value of the DP or if it is the actual profit I made until that point, right? So what I'm going to do is I'm going to initialize the values of the DP with something the answer can never be. Like for example, it can be a negative number, right? Or it can be, or it can be, it can be integer maximum value or integer minimum value. Right? What I'm going to do is I'm going to fill it with a negative number. Okay. Here what I'm going to do is I'm just going to check if dp of I is not equal to -1. Right? If it's not equal to -1, I know for a fact my answer is stored over there. What I'm going to do is I'm going to return dp of I. Right? Here what I'm going to do is I'm going to store it. dp of I equals to max from max of this thing. Right? After this, I'm just going to return dp of I. Right? Perfect. It's the same thing. I'm just checking if the value is there, right? If the value is, I'm going to return it. If the value is not there, I'm going to calculate the value, assign it to dp of I, and then I'm going to return that dp of I. Perfect. Right? Now, if we run it, it should work perfectly fine because our time complexity has reduced from 2 power n to n. Let us. Okay, I think I'm making a mistake. I need to pass dp here as well. I'm going to submit it. Now I should go through. Perfect. The reason I know what is going to happen is because I have a good understanding of how the time complexity is working and how you know each logic or each recursive call that we make is going to affect the time complexity. That's the reason I'm going to I can easily say if it's going to throw TLE or not, right? Yes. So other than that, that is it. This problem is actually an easier problem, right? If you're starting with DP. Right? I hope you understood the solution. I would suggest you to do the same thing. Uh, Either trace a stack call or you know trace it in terms of recursive trees, and yeah, try to do it on your own, and yeah, uh, keep doing it until you get the right approach and you get the right solution in mind. Right. Thank you so much for watching.